Hello and welcome to my video on a simple example using distance on the Keras library. So let's go to it. As you might have seen, I'm assuming you are starting to learn how to use this library, this machine learning library, and as you probably saw, it is relatively simple and straightforward to train a simple network to do something. For example, you need to import the relevant packages and the relevant utilities, etc., and you build your model and you train your model and you have your results. So what's the problem with that? None, of course. But at least to me, what happened to me is when I started learning all of this, if you take some lesson from the internet, and there are a lot of places, YouTube videos, tutorials, and all of those resources are pretty good, are very nice. You can learn a bit from all of that, but sometimes the problem is that all of this machine learning stuff is very hungry for data and big data tables and so on. So when you take a lesson or something in this, usually they will teach you how to build your model, to train the model, and they will provide you with the data. For example, for data coming from some practical application or something like that, or some actual real image if you are doing image classification, and that's okay. But at least in my case, when I'm trying to learn something new, I like to tweak every possible value of the parameters so that I can make sure I'm learning the correct meaning of those parameters, and so that I can feel a little bit, let's say, comfortable when I see all of these epochs, etc., number of layers, and neurons, and the shape of the data. I want to try very different shapes, or categories. I want to try many different categories. And so when you use data that was provided to you, you can't really do much. That's the data. You have to train and use that data. I mean, you might tweak a little bit of things there, but that's what you got. So my idea here was to use a very basic Python package, which is called NumPy, and if you don't know it, if you don't already know it, I suggest you to stop this video and go to some other video to learn how to use some basic function from NumPy. But I'm guessing you probably know something about this if you are trying to use this machine learning package. So a simple idea is to, rather than using data that is provided to you by the internet or by someone, the idea is that in your learning process you should be able to generate your own table of data at your own, as you please, and that you can modify it in any way you want, so that you can check later with your network if you whatever tweaking in the parameters that you might want to do. And so actually with NumPy there is a very simple way to do that, and one possible way is the following. So first, of course, we have to import the relevant package NumPy. This is the standard way, and the first thing we're going to do is to generate an array of numbers. We will generate arrays of 10 numbers, and we will see, or we will try to visualize those 10, each array of 10 numbers as a vector in Euclidean space, in 10-dimensional Euclidean space. So one array of 10 numbers will be a vector in Euclidean 10-dimensional space. So, and of course, since we want an easy way to generate a lot of those vectors, we don't want to put it by hand. So we simply use the random number generator from NumPy, and in particular for ease for making things easier, we just simply use the random integer. So this is the correct command: random.randint, and we will. This is the range in which, from 0 to 10, from which NumPy will generate random numbers, and it will put those numbers in an array from 0 to 10 too. So we have an array of 10 numbers, and where each number is selected randomly from the 0 to 10. So, and for the training dataset, we will generate 10,000 10 number arrays. So we will have 10,000 10. This will be the shape of the whole data set. And for the testing, we'll do the same, but much more smaller, only 100 data vectors of arrays. So this is the very easy part. Now it comes the I wouldn't say hard, because as you can see, you only need one line of code, but this is the relevant part of all of this. So far we only have in our training set 10,000 randomly chosen vectors from 10-dimensional Euclidean space with integer entries, of course. So that doesn't, if you put that into a neural network, it will do nothing with that. What we need to specify is, given an array from this training set, what should be the output, the correct output that we want the network to give us for that initial vector. And we called that data set sorry, I can't remember how to pronounce this in English. But in doing that, we will need to specify what kind of thing are we looking for in this vector to satisfy in order to have a non-trivial answer for the neural network to look for. So, if you know something about the general theory of neural networks, you probably heard that a neural network is a universal approximator of any Borel measurable function. So any Borel measurable function that you can think of, a neural network can serve as an universal approximator for that function. So first, we will try our neural network to approximate a function in the following way. First, what function? I will choose a rather easy one, which is the Euclidean distance or the norm of that vector or array in Euclidean T-space to the origin. So that we can easily visualize what kind of function we are using here. And here you have to be a bit careful, because you have to use the NumPy square root and multiplication and sum, etc. Because if you use the standard Python math functions, these functions will not operate correctly in each of the entry of our array. But the square root of NumPy and the sum and the multiplication will do exactly what we want. So, for example, let's first print our first data set, which is this. Okay, so it is this big. So as you can see, we have 10 numbers, 10 numbers, 10 numbers, and from each one goes or is inside the interval 0 to 10, and it's chosen randomly, an integer that is chosen randomly from that. So we have 10,000 of these arrays. So of course here is showing only the first 3 and the last 3 arrays. So okay, and now we will do the following. We will multiply by itself, and since we are using the NumPy, what this will do is multiply each entry by itself. 8 by 8, 3 by 3, 1 by 1, and so on. And when we do this, what this will do is the sum in, when we put x equals 1, and this will sum in this direction. If we put equals to 0, we will get a different thing. We want this to sum. Our vectors are in this order. This is another vector and this is another vector. So we want to multiply 8 by itself, 3 by itself, and so on, and we want to sum all of that. And then we take of all of that, of that sum, we take the square root. And again, we use the NumPy square root, which will, once we make the sum, this will get transformed into into a single array or with 10,000 elements, because this whole array will be reduced to one number, which will be the result of the sum, and so on. And the NumPy square root will apply that square root component-wise to the first sum, to the second sum, and so on. So in each array, if we print this, well, what we will get is each number is the Euclidean distance to the origin from the tip of that vector to the origin. So if we print again the data, we get this vector, and this first number should be its distance to the origin, and for the second vector this number should be its distance to the origin, and so on. So we have 10,000 numbers here.